Welcome everyone to another webinar hosted by SmokeD together with Association of Independent Fire Experts, also known as SNEP, a series of webinars where we invite experts in their field in order to provide an opportunity to learn, inspire, or open a discussion of serious issues and solutions related to fires. Quick notice, the entire event is being recorded, and in today's agenda we will start with short presentation about forest camp from Ms. Eva Zin, a representative from Association of Independent Fire Experts, also a scientist from Polish Forest Research Institute specializing in dendrochronology, also with a focus on its applications in wildfire research. After that, we will serve the main course, which is the presentation from Mr. Anton Beneslavskiy, an experienced firefighter, forest campaigner, and project lead for Greenpeace Russia, as well as trainer for Greenpeace Indonesia wildland firefighting team, certified incident commander. And Mr. Beneslavskiy also worked on WWF's leading wildfire prevention projects, and he's currently a co-founder and expert for Pyrocene Alliance. To not prolong the introduction, I believe we can move forward. Just after that, we will have a Q&A session moderated by my colleague from SmokeD, Mr. Jakub Nowak. And we will have around 20-30 minutes for the presentation, for Mr. Beneslawski's presentation, and another 20 to 30 minutes for Q&A session, where you will have an opportunity to open a discussion or ask your questions. Thank you, Anton. Thank you, Eva, for being here with us. And I'm handing the floor over to you, Eva. Go ahead.
Yeah, thank you very much. And welcome, everybody. It's very nice to meet you all. I will start to share my screen now because I have a couple of slides for you, but I promise it won't be long. Okay. Yeah, so generally, today I would like to introduce an incredibly interesting event to all of you, which is Forest Camp. That is generally an international wildfire training. And this year's edition will be held in late May in Gołąbki near Poznań in northwestern Poland. And Forest Camp is an event or training which is organized by SNEP, so the Association of Independent Fire Experts. So far, we organized 4 editions already, and in those events, over 400 participants took part in. And what we are very proud of, those people came from 30 countries located on 4 continents. However, what we are more proud of is the fact that those people represented a broad variety, or like a really broad variety of backgrounds. So our participants were firefighters, both indoor and wildland firefighters, forest managers, scientists, land managers, and also people working in civil defense on a daily basis. In all the former editions, we had international teachers. And generally, the main goal of this training is to give the participants the opportunity to familiarize with various aspects of wildland fire, including real-time or real-life activities and scenarios involving fire, and getting introduction into various aspects of fire behavior, fire management, fire fighting, but also burning, with different scenarios and different aspects of all those issues being addressed. Also, for example, including first aid, etc. However, what is also one of the main goals in all that is global networking, having lots of fun and building new connections and new friendships. And of course, on this picture in the upper right corner, we are drinking lemonade. So generally, to make the long story short, hereby I would like to invite you all to join the coming Forest Camp this year. If you are interested, please send an email to the SNAP office or send us a private message on Facebook, and I will now paste those two directions directly into chat of this meeting. And then if you contact us, then you can get the full information package. And of course, the next step would be to register via link which is already open, and this link, which is at the very bottom of the slide, you see, I will also paste directly into the chat window of this webinar. And so far, that's all from my side. I will now copy all the directories to the chat, and thank you very much.
Thank you, Eva, very much as well. And the floor is yours, Anton. Peat fires, specifics, and challenges.
Good time of day, guys. I'm really happy that so many of you joined us, and I'm excited to join this event. I will try to provide you with a short presentation on how peat fires could be addressed and what are the specific features of this type of fires, as well, as soon as that's not the common thing for all of us. And these fires are a bit in the shadow of the big forest fires, which take the first pages of newspapers and all the time in media. Not much people address the attention to peat fires, while these fires are quite tricky, and they could be really dangerous and could cause the long-term lasting effect. I will share my screen and start the presentation. Okay. This one. So, can you see my presentation right now?
Yes, we can see it.
Thanks. So, I will start with a picture which was taken in 2015 by the Greenpeace Russia team when huge, large area peat fires in Bryansk region were hidden by the authorities from the public attention, because these areas were contaminated during the Chernobyl nuclear power accident in 1986, and they were contaminated with the radioactive particles. So there was quite a story to fight these fires. So here you can see the large peatland, the large drained peatland, which is burning. And why I use this picture and this particular fire to start the presentation is that that's the quintessence of what the peat fire could be. Very resource consuming, very challenging, very special, with very specific additional risks which you need to manage, especially due to the specifics of peatlands, the ability to accumulate any type of toxic, radioactive, and other hazardous substances. And I want to express my gratitude to my friends and colleagues from Greenpeace Russia and Greenpeace Indonesia, because my experience in this area was achieved working with them. A lot of them, I fled my country because of the political oppression, and some of my colleagues are still there, and people in Greenpeace people in Indonesia also made some hostilities from the local authorities. So they did not only fight fires and met all the risks of that, but they had all the risks of being non-governmental organization in the countries with a specific understanding of the social situation. So what is so important about peat fires? You can see the map with the black dots, which represent the concentration of peatlands. And if you look at it, you will see that 5 most important and 5 biggest forest regions, such as Northern American boreals, Northern European and Asia boreals, Amazon forests, Congo Basin forests, Indonesian rainforests, they are based on peatlands. These peatlands are to 16% of the peatlands in the world are drained and used for peat harvesting. So they exposed to the fires because of lack of water in these peatlands right now and presence of the human activities. But we should remember that due to climate change and droughts, even natural peatlands start to be vulnerable for fires. And what we see, for example, right now, the dynamics in the northern Canada, when forest fires, large-scale forest fires, ignite peat fires, which survive winters to pop up in the spring and start new forest fires, it's quite a new dynamic globally. The same dynamic we can witness in Siberia, for example, and we in Greenpeace Russia worked with this for some time, and that's quite a game changer because these fires, which are called by media zombie fires, I do not like this name, but it exists. These zombie fires, they change the whole pattern and the whole dynamics of forest fires in these regions. Peatlands is the greatest terrestrial storage of carbon. So when they burn and when they degrade it, they emit this carbon in the atmosphere, contributing to climate change. But also, peat, when it combusts, peat, when it's smaller, produce toxic smoke. There was a calculation that I could mistake the year, but I think it was 2012 in Indonesia or 2014, when it was 100,000 premature deaths caused by inhalation of toxic smoke from peatlands. So also that's an environmental impact. The fires degrade peatlands, destroy them, expose more peat for oxidization, and causes kind of fueling the climate change. And with these aspects, with all this damage, we should keep in mind that peat fire suppression is very resource consuming. I will show it up. And there is some complexity of fighting these fires because in majority, they will require direct firefighting with a large amount of water on the very tricky terrain. So the forecast which we can make based on our experience and researches we made in NGOs which work with peat fires is that more and more peatlands, both natural and drained, will be involved in fires soon in next decades because of the climate change, because of the above mentioned change of patterns, because still we have extensive peatland exploration, which much exceeds the peat restoration programs. Because peat fires are deprioritized in many countries, they are not so spectacular, they not attract so much of public attention. Because of multiple unclarities in prevention strategies, preventing peat fires by peatland restoration requires a lot of resources, and there is a big environmentalist dispute around how to revet peatlands and how to restore them. And because of the lack of resources, a lot of peatlands are situated in the lands which are not managed by powerful and well-resourced agencies. And some of them just unattended. So what are the specifics of the peat fires? I will a bit change the sequence of, and we'll start with the specifics of peat itself as fuel. Excuse me if I'm saying something that everybody knows, just following the structure. So the peat is an organic substance which accumulates for centuries or even 1,000 years, especially in the swampy areas along the rivers. And this substance is quite solid, rich of carbon. And from our wildland firefighting perspective, what is important? Peat can smolder without oxygen excess. So that's a very specific fuel which does not require direct oxygen excess to smolder and to combust. While combusting, peat converts into the very hard solid particles which are hydrophobic. So you cannot feed them, you cannot fill them with the water. You need to use high pressure water jets to destroy physically these solid particles if they appear. If you leave some of this particle not suppressed, not cooled down, not destroyed, not mixed into the dirt, then they will heat up again and restart the fires. The dynamics which we witnessed in many countries where peat fires are not regular and there is no experience of fighting them, that fire services spend few days suppressing a peatland, then for a week they do not have any smoke, but in a 1 week or 2 weeks the fire restarts. It doesn't restart really. It's that this fire was not suppressed properly, because normal wildland fire fighting tactics and strategies are not applicable for the peat fires. Peat fires are hard to detect and to size up until they become of the catastrophic size. On the early stage, that's a small burning spots which cannot be detected directly from the satellites as a hotspots, which hard to detect even if you 20 meters from them. You require very accurate and very concentrated and focused scouting to find all the burning spots. And if it's a peatland, if you miss at least one hot spot, at least one burning spot of 20, if you suppress 19 and leave one behind, then you will have, in 1 month, you will have troubles of the larger scale. So indirect attack, which is used by wildland firefighters in forest fires and vegetation fires, is not really the best option on peat fires, because the only way you can use the indirect attack is to raise up the water level. And as far as many of the drained peatlands are situated in agricultural areas with the villages and settlements around, by droning the peatland, you will drone settlements around. We had this problem when we tried to suppress a large-scale peat fire in Smolensk region in Russia, and we could not raise the water, because if we do, the villages around will be flooded. So once you let the peat fire to grow to the large scale, it becomes hardly manageable. Direct firefighting is also resource consuming. Even a small kind of burning spot requires at least 1 ton of water for each square meter or 9 square feet of burning peatland. At least 1 ton. In reality, it will be more, and it requires 1 hour, 1 and a half of the work of the team. So if it's a peatland which has multiple burning spots, you will need a lot of water, you will need a lot of time, and you will need a lot of time for reconnaissance and size up. Drained peatlands, both abandoned or still used, is a hard terrain. It's not suitable for the heavy vehicles. roads could be obstructed or corrupted. So if you need to bring water or you need to bring water pumping equipment, you will use mainly light vehicles or special swamp vehicles, which cannot carry really high weights, high load, and also that's in many cases that's a lot of walking, a lot of hiking across the very complex terrain with the dense vegetation, with the canals all around. So the terrain itself is quite complex, and there are specific risks which wildfire fighting crew do not meet in the everyday wildfire fighting. So you can see the peatland, the drained peatland, the typical structure of the drained peatland. You see the system of canals which takes the water out of the peatland to make it dry. In the early spring, if we talk about Northern Europe, for example, these canals could be the source of water. But generally in the midsummer, water goes out and these peatlands stay dry. Sorry, you can see the smaller canals. I hope my arrow is also visible. So these smaller canals is an obstacle to drive and to hike across. You need to find the places where you can cross canals. Some of them can be really deep, like 4 meters. So this compromised water regime, because of the draining efforts made, make peatlands an area where the water goes out quite quickly in the dry season. So if you have a drought, the peatland with a system of drainage canals will be dry quite faster than other territories. And which is also quite a complicated stuff, is a property status in many countries, where you either do not have a clear person who's responsible for this land, or you have, like in Indonesia, you have a company which owns this land, and sometimes because they use fire illegally in their business practices, they don't want firefighters to come and witness this. And it's sometimes in Indonesia, it was a big problem to reach the burning peatland because the plantation owners did not allow firefighters to come. That's a specific of the country. Natural peatlands, the fires on natural peatlands occur much more rare than on drained peatlands, but still they can occur, especially right now with the climate change. The terrain is very complicated. It's swamps or moors. So it's a swampy area, which is not suitable for heavy vehicles and very hard for hiking. It's large wild areas. Detection of the peat fires is even more complex than on drained peatlands, and the environmental impact of the fire in the natural peatlands is even higher than on a drained peatland, because these are very fragile and very important ecosystems which are responsible for water generation and hydro regulation, the regulation of the hydro regime of the areas. So how can we respond to this complexity in the growing threat? Unfortunately, I do not see the chat, so if I speak too fast, please let me know by voice. So, as usual, if we have limited resources, if we have a fire with high resource consumption, if we have tactical and strategical complexity, we need to use our resources wisely. The pictures which you see is the same area which was photoed by the drone. On the left side, you see the infrared picture, which was made by special drone with the infrared camera. On the right side, you see the normal picture. And you can see that there is no clear evidence of the peat fire on the picture, on the right picture, on the picture in the right side, but there are clearly visible hot spots on the left side. This is an example of how implication of the infrared vision was a real improvement in our scouting and size up. So I will talk a bit how systemically was built the detection, the early detection of peat fires in Greenpeace Russia. And for a long time before government suspended Greenpeace Russia because of the political reasons, Greenpeace Russia team was the most experienced and maintained the highest expertise in peatland fire response. So we started from creating a so-called GIS layer of drained peatlands. So all the drained peatlands of European part of Russia and big part of drained peatlands in Siberia were mapped. So we created a layer which was a special file which could be uploaded to Google Earth, SAS Planet, whatever other GIS software. So you could see the boundaries of the existing dried peatlands. We gathered information about how wet each peatland is. So they've been divided into 4 types of peatlands according to the level, to the general information about how much water we have in each peatland normally. So that allowed us to understand which peatlands are more likely to catch fire. We combined this GIS information with uploading hotspots from NASA satellite, VIIRS, SPHERES, and MODIS, and created a special software which detected when hotspot hits the peatland or the buffer zone, because hotspots have some mistake in the geopositioning, so you need to take it into account. As soon as you cannot see the peat fire itself by satellite, the fire is not so intensive, do not produce so much heat for the satellite can see it. But we know, in the same moment, we know that the peat fires are ignited by the surface fires normally, by agricultural burnings or illegal burnings. So once this burning is detected by the satellite, we can identify if this burning on the surface could hit any of the pits we were managing. Once we have this alert, we identify how much of the most risky peatlands are affected, and we can make a triage or prioritization. We can choose which peatlands we will check first. So then we deploy teams with infrared drones and infrared tools to make a reconnaissance over the burnt area, because normally the hotspot, the burning spot on a peatland will be on black of something which was burnt previously on surface, and then we apply suppression by ourselves, or we pass this information to Ministry of Emergency or to Forest Service, depending on the property status of the land. And then we provided post-suppression control with the same tools as scouting and size up. You can see this picture in the right side of the screen with the hotspots detected by the satellites, which have been checked by food groups, and part of them were suppressed and part of them were suppressed later. So with such a system of early detection, you can be in place, you can be on scene quite early when peat spots, burning peat spots, are rather small and easy to be suppressed. If we leave this peatland unattended for the month, when nobody will see a large smoke going up, and locals will not detect, because at least here you can see a settlement, but on the north of this, it's an abandoned area with no people there. So if we leave it for a month, then this fire will require multiple vehicles, heavy gear, and so-called pipe systems to bring water and suppress them. We calculated that applying the early detection system could decrease the cost of managing peat fires in the area 1,000 times. So the cost of early stage detection and suppression was 1,000 times less than cost of suppression in August, September, when these fires become highly manageable. And also that means that we need much less people and much less vehicles, much less crews to maintain the situation, to manage the situation, than it will when the fires become large, especially when they are accompanied with the forest fires. So the process is simple. Detect as early as possible with all the scientific and technological means you can apply. Suppress directly on early stage when it requires limited resources, and then apply control. Normally, we revisit the suppressed peat spot in 1 week and then in 2 weeks to check that the fire did not start again. It seems very simple, but when it comes to implementing all this, there was a lot of troubles. There was a lot of fight with authorities who wants to show that they doing a great job. So they need a fire to be big to show it on the TV, and then bring an aircraft dropping water, which is in peat fires is totally useless. So, but still, the situation can go out of control and could be unmanageable, especially if we talk about remote areas, less populated areas, abundant agricultural lands, abundant rural areas. So we still keep in mind indirect strategy. So as we say, if you can suppress, drone it. But we should remember that if in forest fires, normally indirect fire suppression, indirect strategy is number one. And if I go to, when I went to Siberia to fight fires, we mostly dig and burn. But when we talk about peat fires, building dams and so applying the indirect suppression is the last measure, because it's very harmful for environment. It could impact settlements around. It can change the whole ecological situation in the ecosystem. Because the indirect suppression in peatland is not digging and burning. It's building dams to raise water and just drone the peatland, drone the fire. So we should assess always environmental and economical consequences, and we need professional hydro engineers to calculate the whole hydrology of this project. Kind of, it's not just a control line and burning, which already requires a high level of experience and expertise, but it's a very specific knowledge, hydroengineering, which doesn't exist in the normal wildland firefighting crews. So you would need an expert, which is not the common thing to find. And also, this is a very high cost and resource consumption. These works are costly because you need to provide a proper hydroengineering in the very tricky terrain with a very tricky access, no roads, swampy area, which is not suitable for heavy gear. So you can imagine that if you did not manage the peat fires on the early stage, when it was cheap and relatively simple, then you will need the whole project for this. But what is important to remember, let it burn is not an option if we talk about peat fires. First of all, peatlands do not have fire as part of the natural dynamics if we talk about peat itself. The surface vegetation could burn in natural conditions, but normally peat itself should not burn. And when peatlands were in a natural stage, it happened that the surface fire goes when the peatland is rather moist, so there was no ignition of peat itself. Now we have peat burning, and peat should not burn. It's like burning a fossil fuel for nothing. So that means that we cannot leave peat fire burn within the control perimeter. We should suppress this fire, and it could be quite challenging and require a lot of effort. So also we need to remember always as firefighters that as well as we have a very specific fuel, specifics in topography, and specifics, and because of that, respectfully, we have a specifics in fire dynamics. Peat fires are slow, but they are tricky. They develop underground. They could be invisible. You could be trapped. So there are specific safety aspects, and there are specific risks. And as soon as peatlands are normally natural landscape, or at least it's a lot of vegetation there, we always have a risk of converting the peat fire into the vegetation fire on the surface when we have a combination of risks together, specific to the peat and specific to the normal surface vegetation fire. So the picture on the right is me and my colleague in Bryansk region in these radioactively contaminated areas. So I use it to illustrate the specifics, the safety specifics, and possible risk combination. The thing is that peat, as I said before that, peatlands tend to accumulate heavy metals, radioactive particles, toxic particles, poisons, and so on, because it's like a sponge which take all the, what's the proper word here, shit, which goes through with the water flow. So once the peat fire comes, all this toxic, heavy metal, radioactive particles will be excavated and thrown away with the smoke. So you see us with a special radioactive protection over our yellow and green. And you see the amount of water we put in the fire spot because we needed to suppress it directly. So what we should remember about peatlands when we try to assess our risks and mitigate them. Peat smolders with a temperature of 5 up to 700 degrees Celsius. It can smolder underground, creating so-called caverns, which are hidden from the site. They have a small burning spot on the surface and much larger cavern underground, which is not visible. So it could be a deadly trap for a firefighter if firefighter falls in, if ground collapse and fall into this cavern. And burn injuries are quite terrible. Every time we had huge peat fires in Russia, there were few firefighters, or especially military, which were involved in firefighting because of lack of experience, who've been injured or killed by peat fires, which seems to be relatively calm, with no big flames, with no a lot of smoke. So peatlands is a tricky stuff. They create a false feeling of safety to unexperienced people while they create these traps. Even a heavy vehicle or truck or four-wheel drive can fall down in such a cavern fully and burn. Even though peat fire do not have such impressive dynamic like a light fuse fire or intensive forest fire, still smoldering could travel under the ground and pop up in unburned vegetation, creating unexpected sources of ignition and restarting the vegetation fire around you. So peatland could act as a very unpredictable element of general forest or bushfire dynamics. And as I said, it accumulates a lot of poisonous, hazardous substances. So you should always think about it and try to estimate if there are any sources of such hazardous materials up the rivers, up the streams, which can be then stored and sunk in peatlands, because you will never know before you get them. And we always had radioactive measurement equipment with us, but we knew that these areas are contaminated. But there is a lot of peatlands which are contaminated with, for example, toxic materials which came with a river flow, with the water streams. So we need to think out of our typical wildfire risk assessment box and try to understand what could be stored in these peatlands. And also, if a peatland situated in the areas where was a warfare, like currently Ukraine, because of this bloody war, and Western Russia and Eastern Germany, so there could be a higher potential risk of unexploded ordnance because of the swampy area provokes shells and bombs not to explode, and they could be stored in the peatlands for decades, being conservated and ready to explode when we fight fires there. So if any questions, you can ask them now, or you can address me directly. I'm working as a consultant, and Pyrocene Alliance will be happy to provide consultancy and support those of you who need this information on peat fires. So I will stop my presentation here. And I hope that everybody could follow my quite a fast speech. Thank you very much. Now, if you have questions, please go on.
We've got the first one. Is there a will in Russia to extinguish every peat fire, as they might be in super huge areas without any access? And what will you do in an area with villages, as you said?
So currently, I'm not really familiar with what the intentions of the Russian government, because I'm outside of the country for 2 years. But generally, there was the law which required all pit fires which situated on so-called lands of municipalities and agricultural lands and forest lands to be suppressed. In reality, of course, some of the peatlands could be, some of the pit fires could be unattended just because of the lack of resources. But the policy was that pit fires must be suppressed, all of them. If we talk about remote areas, that's in northern Siberia, for example, where these fires mainly happen in natural condition peatlands. That's the same situation as like northern Canada. That's very hard to detect. Mainly, it's very hard to understand that you have a burning peatland unless you have a forest fire created by this. And there is still no clear solution for that, as far as I know. My colleague who's still in Russia, he tried to work out this problem, and I know that there is some progress, but that's a very hard topic to explore, because expenses of fighting peat fire in a very remote area, like 700 kilometers from the nearest settlement, or even 1,000, are so high that government will not deploy such resources, will not cover these expenses just for one hotspot.
Thank you for this answer, Anton. And we have a follow-up to that question. Will a peat fire survive a winter under the snow and burn for several years, as it has its own oxygen source? Will the change of permafrost situation change the case?
So I see that there's a Will of Agris to make a comment. So if we can manage this, but I will answer the second question. Yes, peat fire can survive, especially in the natural condition peatlands, can survive the winter. We do not have right now clear evidence that there are peatlands which were burning for a few years in a row, but theoretically it's possible. Melting of permafrost will, of course, change the situation, but the predictions are quite unclear. What exactly gonna happen, because there's very few knowledge about what is under permafrost itself and how the whole picture will change.
I see. Thank you for the answer again, Anton. I received an option to give you the voice of others. Go ahead.
Can you hear me?
Yes, we can.
Okay, well, good evening, Anton. Dobri večer тебе iz Rigi.
Здорово, родной.
So I will give a very short comment. So if we are talking about the peat fires, it's quite typical as well in Latvia too, because we are the typical northern country, and actually the Latvia is the small country, but we have a very big amount of the peat areas from the total area, and then the wetlands. I believe that the good idea, what we can suggest the colleagues, the real basic advice is, so we must to know how big is the possibility that we have possibilities to deal with the peat fires. Because 2 years ago, we participated in the preposition, European Union preposition program in Portugal, and the Latvian firefighters tried to explain to the Portuguese colleagues what does peat is, because the certain countries doesn't know at all in some places what does it means. And then we explained that this is something you can buy in the gardener shop and where you are planting the flowers at home, and it's came probably for the Northern Europe. So then they understood what does it means. It's a typical for the Baltic states, from the Russia, for the Finland, for Ireland. And yes, in Latvia, what we are doing when we had such problems, so we always must remember that it's quite dangerous. Maybe not fall with the tracks in the cavern, what the Anton mentioned, but we can simply stuck, and it's happened quite often. You get stuck, then you're running out from the water, and you can burn your fire truck when the fires approach. What we are doing, we try to get information how thick is the layer of the peat. Maybe it's in some places only some 50 centimeters, maybe it's 1 meter, maybe it's 2 meters, and maybe more. I know that somewhere in Russia, the layer of the peat is really big, more than 3 meters and so on. And if you are familiar about the thickness of the layer, then you can already discuss about the tactical attempts how to do and what to do to solve the problem. Normally, we are not trying to deliver the water by the fire trucks because it's the waste of the fuel. We try to lay down the long hose lines if there is the necessary to do this. Of course, the Baltics, the Latvia is not the Siberia, and there is not so huge distances. But we try to find the water source, open water source, then we lay down the hose lines, sometimes 1-2 kilometers, it's quite long, and start to deliver the water. And then you send the single teams of 3-4 firefighters. You just using the peat fire nozzles, dig them into the ground, and then some 10 minutes, 15 minutes, it depends, they are working. And then you just take it out and push in the ground, in the peat, some 3 or 5 meters next from this initial place. And then gradually we are moving forward. Sometimes we're digging around with if it's possible to use the caterpillar excavators. We're digging around, then we are looking how the water in these digged trenches is rising, and what the Anton side try just to drone this area. But yes, we are lucky we have no so big peat areas. The biggest problem for us is the peat production areas, because there is open space, and if the winds blow, so the small particles, the peat dusts is rolling on the surface and causing again the new places for the new fires, and it's rolling quite fast, and it's one of the major problems. And very big problem for us is as well in these peat production areas. Normally, when you're producing the peat, you are making the big piles of the peat. So you can produce in the two ways. One is for the gardening. You collect the big piles, and the one is when you cut and you're making the like a small bricks. And if the fire reaches these places where there's a big pile or the bricks for the drying, then you got the problems, because it's a burning with the high intensity, and it's almost impossible to suppress. But yes, actually, what we do, we just try to supply the water, the huge amount of the water, and gradually moving forward, 3, 5, maybe even less meters. And if there is a possibility, but it's expensive, of course, then we use the wetting agents. Yes, it's maybe not always cheap. Nowadays, the wetting agents is quite environmental friendly, but it's expensive. But sometimes there is no possibility, because, as well, I will remember what Anton said. When the peat is burning, they produce a lot of tar. And then this substance of the burning peat becomes greasy, oily, and it's absolutely reject the water. And only way you can get the best result is use the wetting agents. This is how we do. But of course, yes, once more, we have no such big areas of the peatlands, but the problem still exists. And one thing we must remember always when dealing with the peat areas, if you have the trees growing there, the 95% roots is burning out, and then every tree becomes a silent killer. You never know at what moment it will fall down. The pine, with the Latvian typical pine, it's Pinus sylvestris, but with the spruce, which is the Piceabies in Latvia, the mine species. The root system is different, and spruce is 100% is falling down. So the peat root system is a little bit different. It's like a pole in the ground, but the spruce is going up to the ground surface, and it's always quite dangerous. We lost some vehicles in the peatlands, forest lands with the huge percentage of the peat, and we lost some vehicles because trees just fall down and hit the vehicles. So fortunately, the personnel wasn't affected. So this is my experience. Thank you for possibility to join.
Just briefly to respond on it, yes, Agris, that's amazing that you bring up. Unfortunately, we could not stop on all the details with a way of fighting fires. We use small amount of pumps which we carry on us, and it depends on the terrain. But what is important about Agris' comment is that, as I said, the conditions could be very different, and we will apply the tactics and strategies accordingly. But anyway, you see that there is a lot of similarities in how peat acts, and unfortunately, it's different from what normal, like say, traditional wildfire fighting requires. So I see there is a question about remote detection. If there are any hands up, or I can answer this question.
You can go ahead. I just wanted to say thank you, Agris, for your input.
So there was a question about remote detection which could be used. So the main thing is that kind of there is nothing special about using drones with infrared cameras. We are not kind of pioneers here. They are used regularly. The thing is that they could be adjusted to see the even a small even a low intensity smoldering under the tree cover. So depends on which size of area we're talking about. It could be kind of at a plane shape, like plane drones, or it could be copter drones. You should identify your tactical situation and understand which type of drones is better. In your case, I would say that what I want to mention that nowadays, even the smaller drones, kind of really you can carry in a backpack. These drones can carry quite a powerful infrared camera, which is used. What I spoke before is the system of satellite imaging combined with a specific GIS tools. And if you have a territory you want to protect, you can use, of course, we would need to see your situation kind of in details to answer if it's possible to use this combination of GIS tools and satellite hotspots detection. But if it's possible, then you can create quite an automatic software which will alert you when you have fire passing your area, and then you know where to apply your drones. Because it's very good when we know in advance where we need to use the drone to reduce the area which we will fly over. And thank you for this example from the Czech National Park, which I think that's a great example how this technology could be used. In Indonesia, our partner NGO was using the aircraft-shaped drones to fly over the peatlands during the high season, and they covered quite a huge area without getting out of the office. So they were launching the drone from the roof of the building and then waiting for it to arrive back with the information about burning peatlands.
Yes, thank you for all the inputs, Ms. Janet, Agris, and David. All of these discussions, I think, enhance the whole discussion about the issue. I believe we are kind of running out of time, but I will allow one last question. If there is any, we can also allow you to speak if you would prefer to. Well, I believe that would conclude the Q&A session then. Thank you again, Anton, for your presentation. It was very insightful. Thank you to all of the participants for coming and staying with us. And one more favor I would like to ask you after the webinar will be finished, please do participate in a very short survey about the webinar's organization that will help us improve the platform and everything for future matters.
And Michael, can I make a short thing? So if any of you have more questions on peat fires, so please reach the organizers and they will provide you with my email and we will stay in contact and I will try to thank you.
Absolutely. Absolutely. After every webinar, if you would like to reach out to the expert, we'll always help you out. It's the essence to open the discussion and everything. Thank you again for participation. Eva, would you like to add something?
Yes, I would like to show again the final slide of my presentation, just to invite you again to the forest camp late May this year in Gołąbki in Poland. And in case you would have some further questions related to the event, just send us an email or contact us directly on Facebook. Thank you very much.
Thank you very much, and have a lovely evening or good the rest of your day. Depends on your times, and thank you.
Thank you.
Thank you. До свидания. Удачи.